Hi math students, it's Mr. Hajgassim here, and today we're going to learn how to factorize quadratic equations where the coefficient of x squared is 1. Now that will all make sense. It sounds a bit difficult, but I can assure you it will make perfect sense as we progress. So just to do some recap, we need to be able to factorize basic equations. So if we were to told factorize 6x plus 18, what that means is putting this expression back into brackets. So what that would look like, if I can just get my pen. So what that would look like is we need to find the highest common factor of these two terms. So what's the highest common factor of 6x and 18? Well, the highest common factor of these two terms is going to be 6, because 6 goes into 6 and 6 also goes into 18. Now 3 is also a factor of 6 and 18. 2 is also a factor of 6 and 18, but we want the highest common factor. Then we draw our brackets. And now you have to ask yourself, 6 multiplied by a number or a letter, or in other words, a term, to give us 6x. Well, this is going to give us x. Whoops. I'm just going to undo that. That's going to be x. And then 6 multiplied by a number to give us 18. Well, that's going to be positive 3. So we have just factorized this expression here. And if we were to expand this again, we should get what we originally started. So 6 times x will give us 6x. And 6 times 3 will give us 18. All right, so you can pause the video and have a go at this one. So if we think about this, what is the highest common factor of 21a squared and 7a? Well, the highest common factor is going to be 7 because 7 goes into both numbers, and they both also have 1a. So on the outside, we're going to have 7a. Then we draw a bracket. Then you need to ask yourself, 7a multiplied by a number or a letter to give us 21a squared. So that's going to be 3a. 7 times 3 makes 21. A times a makes a squared plus 1. And again, if we were to expand this, 7a multiplied by 3a is 21a squared. And 7a multiplied by 1 is just going to be 7a. Okay, so this is basic factorizing. Now we're going to look at quadratics. And I'm just going to clear this. And let's move on. So all quadratic equations contain the term x squared. Quadratic equations are written in the form of ax squared plus bx plus c. And generally quadratic graphs have 2 solutions. Now lots of new words here. The word solution, that just means the point at which a quadratic graph intersects the x-axis. So at the point where y is equal to 0, what are our x values? And this is what we want to find out when we factorize quadratic equations. Now, if I just go back, well, actually, we mention it here. C is the y-intercept, and that will become clearer in a moment. So C here, this is the point at which we intersect the y-axis. So this point here would be our C value, this point here would be our C value, and this point down here would be our C value as well. So I'll just mark them quickly, just so you can see. So this point here, this is the point where we intersect the y-axis. So this is our C value. This point here will also be our C value, and roughly this point here will also be our C value. So C is our y-intercept. Now moving on to the next slide, if I can just clear all the annotations. And so quadratics, where are they used? Well, a firm might graph their profits against their price. I know it says cost here, but actually that should be their price. You might, as a business, graph your costs or prices against your profits. So at what price will you maximize your profits? Well, that would be at this point here. this is where you would maximize your profit. So a firm may decide to set their price at, for some reason I can't quite see this, would set their price at the cost on the x-axis. If I can just fix this, okay, that's better. So they would set their price at approximately, oh, sorry. There we go. I can't quite hide this. So they would set their price approximately at this value here. And again, if they were to set their price over here or over here, at these points, their profits will be zero. So at approximately 100, and I would say that's about 25 pounds, their profits would be zero. So over here, the profits would be zero. At approximately 340 pounds, their profits would also be zero as well. Likewise, here we have a long run average cost curve of a firm. So as a firm increases their output, their costs might start to fall up until this point here where we have C. Beyond this point, if they start to increase their output, their costs start to rise, and they can graph this using a quadratic equation. And that's quite complex, and we're not going to cover that, but I'm just showing you where you might use quadratic curves in the real world. All right, and moving on. So here's a quadratic, and we want to we want to solve this quadratic equation. And what we need to do is think of two numbers that add to give b being 7, or the coefficient of x, and multiply to give us c being 12. So the same two numbers that would be added to give us 7, and the same two numbers that would be multiplied together to give us 12. What are those numbers going to be? Well, the numbers will be 3 times 4 give us 12, and 3 plus 4 will also give us 7. So these two numbers will satisfy both conditions. And if you were ever stuck, you can think about the factors of 12. So you could think to yourself, well, I could use 1 and 12. They would multiply to give us 12, but they won't add to give 7. You could have used 2 and 6. Again, they would multiply together to give us 12, but they won't add together to give us 7. And then you could have thought about 3 and 4. These two numbers multiply to give us 12, and they also add to give us 7. So sometimes if you're stuck, if you can't quite see what the numbers are going to be, just list the factors of C, or in this case of 12, and then you can go on from there, recognizing that 3 and 4 will make 7. Now what we need to do is rewrite this equation here. However, we're going to break 7x down into 3 and 4. So we can rewrite this as x squared plus 3x plus 4x plus 12 equals to 0. Now, again, notice 3x plus 4x makes 7x. So nothing has really changed apart from the fact that we've broken this down into 3x and 4x. And this is required as part of our process to find the values of x. Now, once you've done this, split your equation into two halves. So this is one half here, and this is the other half here. Include the sign as well, as you need to know if you're dealing with positive 4x or negative 4x. So in this case, we're dealing with positive 4x. Now factorize each of the expressions that you've created. So we have x squared plus 3x. So we want to factorize this as we did for the starter on the first slide. So the highest common factor here is just going to be x. And then on the inside, we're going to have x plus 3. And just to double check, x multiplied by x gives us x squared. X multiplied by 3 will give us 3x. Now here, the highest common factor of 4x and 12 is just going to be 4. And then on the inside, 4 times x to give us 4x, and 4 times 3 to give us 12. Now, notice what happens here. Both of the brackets are the same. And if you've done your workings out correctly, these two brackets should always be the same. So if you get different answers in the brackets, go back and check your work because you've probably made a mistake. These two brackets should always be the same. Now what we do, we take down one of the brackets. So we bring down x plus 3. And then we have x and 4. So we need to put those in a bracket as well. And we're just going to do x plus 4. So add those two together. And that will be equal to 0. So now what we've done, we've factorized this expression. We've put this back into brackets. And if we were to expand this, this expression here, we would end up with what we started originally. Now, I'm not going to expand this, but if you were to try and expand this, you will get exactly what we have up here, so what we started with. Now, here's the bit where we need to solve for the values of x. Now, if this quantity here is multiplied by this quantity here, because x plus 3 bracket x plus 4 just means a multiplication problem, will give us 0. One of these two will have to be equal to 0, because this being equal to 0, 0 multiplied by whatever the value of this is will give us 0, or if this has a value, this multiplied by 0 will still give us 0. So we can say either x plus 3 is equal to 0, or x plus 4 is equal to 0. So we're just trying to find the values of x. Therefore, if x plus 3 is equal to 0, x has to be equal to minus 3. Remember, if we substitute minus 3 in here, minus 3 plus 3 makes 0. And over here, x has to be equal to minus 4. And these are the values of x. So we've solved this quadratic equation. And again, if we put, if we substitute minus 3 in here and minus 4 in here, this statement will be equal to 0. Now, why have we found the values of x? Well, the values of x are the points at which a quadratic graph will intersect the x-axis. So if I was to draw a rough sketch here, actually, I've got it on the next slide, so I'm not going to do it here. But before I do, I'm just going to show you a really good website, which is called Geogebra. So if I can just leave the slides. So I'm just going to, and if we go on Geogebra over here, we can see what our graph would actually look like. So we said the values of x are minus 3 and minus 4. And I think I will have to clear all the annotations. Right, so we said the values of x are minus 3 and minus 4. And if we look, if we were to graph our quadratic, these are the points at which we intersect the x-axis, so at minus 4 and minus 3. And we said our y-intercept, or our c-value, is 12, and we can see our graph intersects our y-axis at the coordinate 0, 12 over here. So if we were to sketch our graph, it would look something like this. And I will just go back into present mode. And I will move this here. So we established that x is equal to minus 3 or x is equal to minus 4. And if I was to sketch our graph, we'd say minus 4 is over here approximately, minus 3 would be approximately here, and 12 we can say would be approximately here. Now notice I haven't drawn this accurately. It doesn't matter because we're just sketching a graph. So this would look something like this, going through 3, and this is really badly drawn. In an exam, you will probably be given your X and Y coordinates. So this would be something like this rather. And again, if you do draw it like this, it's not pretty good. So I'm just maybe going to redo this. So let's say -4 would be about here, -3 you can say be somewhere around there. I've left a big gap just so I can draw my graph a bit clearer, and 12 might be here. So our graph is not drawn to scale, and we're just making a rough sketch that would look something like this. And obviously, if you use Geogebra, you can see exactly what the graph will look like. Okay, moving on to the next slide now. So I'm just going to clear all my drawings. We have another problem. Now, this time we've got negative values. So we've got x squared minus 2x minus 8. So if you can remember, we would have to add we would have to add two numbers to give us -2, and we would have to multiply two numbers to give us -8. So what could those numbers be? Now again, you could think about the numbers that would multiply to give us -8. So we could have 1, and in fact, think about numbers that would multiply to give us 8 first. So we can have 1 and 8, we can have 2 and 4, and these are the factors. So our numbers are going to be either 1 and 8 and 2 and 4. Now the difference between 1 and 8 is 7. The difference between 2 and 4 is 2. So these are the factors we need to deal with. But we are dealing with negative numbers. So one of these will have to be negative. Now, if I was to use -2, well, -2 plus 4 is just going to be 2. So this 2 value will have to be positive. Now let's try making 4 negative. -4 plus 2 does give us -2, and -4 multiplied by +2 will give us -8. So our values are going to be 2 and -4. So 2 plus -4 is the same as 2 minus 4, and 2 minus 4 will give us -2. And likewise here, 2 times -4 will give us a negative answer. Remember, rules of negative numbers, a positive multiplied by a negative will give us a negative answer. Now, so what do we need to do? We need to break down this -2 into 2 and -4. So we can rewrite this as x squared plus 2x, because we're dealing with +2, minus 4x minus 8, and that will give us 0. Now again, notice here, all we've done is broken this -2 down into +2x and -4x. Now we need to split this equation into 2 halves. So I'm just going to use a different color pen, half, and this would be the other half. And again, make sure you include the sign because you're dealing with -4x, not just 4x. Now, we need to factorize each of these expressions. So this is going to be x on the outside, because x is the highest common factor of x squared and 2x. So x times a variable, that's going to be x to give us x squared, and x multiplied by 2 will give us 2x. So we've literally factorized this into this expression here. Likewise here, what is the highest common factor of 4x, minus 4x and -8? So we can just put -4 on the outside. This is going to be x on the inside. -4 times x gives us -4x. And now notice how I said previously in the last slide, the brackets should be the same. The same numbers and terms should be in the brackets. So this will have to be +2. And that is correct, because If we were to do negative 4 multiplied by positive 2, that will give us negative 8. So this expression here is the factorized version of this expression on the top. Now, what we need to do is bring down only one of the brackets. So x plus 2. And then we need to add these two together as well. So x plus minus 4 is just the same as x minus 4. And that is equal to 0. Now, seeing as we're multiplying the brackets together, one of either this bracket or either this bracket has to be equal to 0, because 0 times a value will give us 0, or if this has a value, this multiplied by 0 should still give us 0. So we can write x plus 2 is equal to 0, or x minus 4 is equal to 0. So therefore the value of x is going to be x is equal to minus 2, whoops, or x is equal to positive 4. And that is true, because when x is positive 4 minus 4 is going to be 0, or negative 2 plus 2 is still equal to 0. So these are our x values, or in other words, the solutions that we are finding, the solutions being the points at which we intersect our x-axis. So we're going to be intersecting our x-axis at minus 2, and our other solution is at positive 4, and our y-intercept would be at approximately, well, it will be at negative 8. So if we were to draw our graph, it would look something like this, intersecting at negative 8 on the y-axis and positive 4 on the x-axis. Again, this is a rough sketch, it's not drawn to scale, so please don't take too much notice of that. If you go on Geogebra, you will be able to see the accurate sketch of this graph. Okay, moving on. Now let's try a worded problem that will involve quadratic equations. Now, again, I have actually got the axes here, so what I can do is clear all drawings. And again, just to do a recap, so minus 2 would be roughly here, positive 4 would be, say, there, negative 8 could be here, and our quadratic will look, sorry, I should go through here, intersecting at negative 8, and that's what it would look like. Again, it's a rough sketch. It is a little bit hard with the mouse to draw this perfectly accurately, but in an exam, make sure you just use your pencil and do a nice rough sketch. And I'm just going to clear the drawings and move on to the next slide. So here's a worded problem. It says the length of a rectangle is 5 centimeters more than its width, and the area is 50 centimeters squared. Show that the length of the rectangle is 10 centimeters and the width is 5 centimeters. So the answer is actually given to us, but we need to see how the answer has come about. So first, let's draw a rectangle. So this rectangle has an area of 50 centimeters. Its width, or its length, is 5 centimeters more than its width. Now, we don't know what its width actually is, so we can model that as W, and the length is therefore going to be 5 centimeters longer than the width. So we can model this, or form expression as W plus 5. So the length is W plus 5, the width is just W. Now, the area of a rectangle is the width multiplied by the height, so, or the width multiplied by the length. So that's going to be W multiplied by W plus 5 should give us 50 centimeters squared. So we can write this out. This is our first step. So W multiplied by W plus 5 equals 50, right? So this width multiplied by this height will give us 50. Now, we need to expand this. So what we'll end up with is w multiplied by w, which is w squared, plus w multiplied by 5 is just going to be 5w, and 50 stays as it is. Now, we have a quadratic equation here. We have a squared term in our equation. So this is going to be a quadratic. So to solve this, we need to bring all the terms on one side. So we want to equate this equation to 0. So what we can do is subtract 50 from both sides. And what we're going to end up with is w squared plus 5w minus 50 is equal to 0. Now we have a quadratic equation, and now we just need to solve to find the value of w. And we need to think about, so two numbers that add to give us 5, and the same two numbers that multiply to give us minus 50. Remember, we're dealing with negative 50 here, so it's not going to be 50, it's going to be negative 50. So that's going to be, well, the factors of 50 are 10 and 5, and 10 and 5, the difference between them is 5. So we need to think about 10 and 5. However, one of them has to be negative, so 10 plus negative 5 is the same as 10 minus 5, which is 5. Therefore, 10 multiplied by minus 5 is equal to negative 50. So this is going to be w squared. We're going to break this 5w down to minus 5w plus 10w minus 50. And that is equal to 0. Again, split your equation into two halves. So that's one half, and that's the other half, and factorize each halves. So the highest common factor of w squared and 5w is going to be just w on the outside, w on the inside, minus 5. And likewise here, the highest common factor of 10w and minus 50 is going to be 10. So 10 on the outside, 10 multiplied by w gives us 10w, and this will have to be minus 5. And I know I've done this correctly because both of our brackets are the same. Now I'm just going to move over here. So what we need to do is bring down one of the brackets, so we can do w minus 5. And we need to add these two together. So in our other bracket, we're going to have w plus 10, and that will be equal to 0. Now again, either this is equal to 0 or either this bracket is equal to 0. So we can say w minus 5 is equal to 0, or w plus 10 is equal to 0. Therefore, if w minus 5 is equal to 0, w has to be equal to 5. Or if w plus 10 is equal to 0, w will have to be equal to minus 10. Now we've got two values for w. However, we're dealing with length, and we can't have a negative length, so this can't be the value of w. However, this w here is a positive value, so we can substitute this in place of w. And if we do that, we would get the width will be equal to 5, and the length will be 5 plus 5, which equals to 10. So by creating a quadratic or forming a quadratic equation, we've shown that the length is 10 centimeters and the width is 5 centimeters. Right, so this was just an example of how you can deal with quadratics in worded problems. Just to do a quick recap then, and I'm just going to clear all the drawings And if I go back to a previous slide, so to factorize a quadratic, all quadratics are written in the form of ax squared plus bx plus c, where c is the y-intercept. A and b are the coefficients of x squared and x, coefficients just being the numbers in front of our variables. Now notice here, there is no number in front of x squared. If there is no number there, it means a is equal to 1, because we could rewrite this as 1x. If I can just annotate. So we could rewrite this as 1x, but traditionally you wouldn't do that. So if there is no value in front of x squared, know that a is equal to 1. Once we have that in place, or once we have our quadratic, then think about what numbers add to give us 7 and multiply it to give us 12. You can lay your work out like this, and then think about the factors of 12. And then once you've picked the factors, see what the difference between the factors are. So the factors of 12 are 3 and 4. The difference between them is 1. Or think about how, in fact, in this case, we need to add them to see if we get 7. So again, 3 and 4 will satisfy both conditions. And then we need to break this 7x down into 3 and 4, and then show your workings and do the steps that we have introduced in this lesson. Thank you for listening, and I hope you have a very good day. Bye.